Okay, let's work on some equations with fractions. We're going to solve equations that have several fractions in them, or have more than one fraction in them. Let's take a look in our textbooks at the Mark Dugopolsky Elementary and Intermediate Algebra textbook. At section 2.3, the exercise is on page 108 and 109. We're going to look at some equations with fractions down on page 108. I'm going to start with number 24. Before we start, please make sure you have your textbook out and also make sure you have your notes from class out. We took notes on solving equations with fractions. So pause the video and please take out your notes. Okay, let's get started. I'm going to start with number 16 on page 108. Number 16 is a over 4 minus a over 2 equals negative 5. This is trying to be an a here. Let's make that look more like an a. Okay. A over 4 minus a over 2 equals negative 5. The first step, since we don't have any distribution, is to actually make sure that every term is a fraction. So we already had a over 4. We have a over 2, that's a fraction, and we had equals minus 5. And so what I did was I drew a line under the 5 and put it over 1 and turned that into a fraction. Excellent. Okay, our next step, if you look in your notes, is to identify a common denominator. Off to the side, let's write CD, and we'll see what we come up with. Since we only have numbers as denominators, we need to look at 4 and 2 and 1 and determine the smallest number that each of those goes into evenly, the smallest number that is divisible by 4 and 2 and 1. It's called the least common multiple. 4, the smallest number 4 goes into is 4. 2 also goes into 4, so let's say that our common denominator is 4. Okay. We're going to use the method where we actually get a common denominator, turn every fraction into a fraction with a common denominator. So I'm going to draw an arrow under each one, and I'm going to rewrite this equation with open numerators, but with the new denominators, with the common denominators. Okay, so I have rewritten this equation. There are no numerators here yet. Let's use another color to show how we'll get our numerators. There are no numerators, but I've written in our common denominator. And so I need to take a look at this first fraction here, this first fraction, and I'm going to say 4 times what turns this denominator into the common denominator down here, 4. Well, 4 times 1. And so what I do to the bottom of this fraction, I need to do to the top. If I multiply the denominator, I need to multiply the numerator by the same number. So if I multiply the bottom by 1, I need to multiply the top by 1. So a times 1 is a. Okay, let's look at the second fraction. I need to turn 2 into 4 with multiplying. 2 times 2 equals 4. And so if I multiply the denominator by 2, then I need to multiply the numerator by 2. Well, a times 2, I know we don't think about it this way. We don't think about a times 2, we think about it as 2a. Okay, let's move to this final fraction. 1 times 4 is 4. And so I need to multiply the top by 4 as well. If I multiply the denominator, I need to multiply the numerator by the same number. Negative 5 times 4 is negative 20. Excellent. Okay, I have now achieved my goal of having the same denominator for every term. Every single term. I did not just do the terms that started out as fractions. I took this final number in my equation that was not a fraction, turned it into a fraction by putting it over 1, and made sure that it also has the same denominator as every other term. Once that happens, I can do something. I can multiply both sides of this equation. I can multiply both sides of this equation by the same number and make all of these denominators cancel. If I multiply this side by 4 over 1, and I multiply this side by 4 over 1, then this 4 over 1 distributes to each of these terms, and the 4's cancel each time. And so what this means is, if you have written your equation a over 4 minus 2a over 4 equals negative 20 over 4, you can follow the rule every time that if you've gotten the same denominator in every single term, then you can cross them out. They cancel each other out, because if I multiply the left side by 4, the denominators will cancel when you reduce the fractions, and if I multiply the right side by 4, the denominators will cancel when you reduce the fractions. This is an excellent way to get rid of the fractions, eliminate fractions. So we're now left, if we come down just a little bit here on our paper, we're now left with a minus 2a equals negative 20. Let's take a look at solving that. If we just come right over here, a minus 2a is negative a equals negative 20. I'm going to divide both sides by negative 1, and a equals 20. And there is our answer for this problem. Remember, to start, we turned every single term into a fraction. Next, we came down and we rewrote each fraction with just its new common denominator after we, had identified the common denominator. We then did work on the original fractions to determine the numerators of the new fractions in the new equation. Once we had all the same denominators, coming down below here, once every single term has the same denominator, they cancel out. And then you can take the top part of this the top part of this equation, each of the numerators, look at it as its own equation, and solve for the variable. Okay, let's try another one. I'm still looking at page 108. I'm going to look at number 24. Number 24, get some black ink here. Number 24 is 1/3 x minus 2/5 x equals 5/6. Let's write it. 1/3 x minus 2/5 x equals 5/6. Okay. I see a couple of things, or I see something that we should probably attend to before we go ahead and get a common denominator. And that is that these x's are not really on their fractions. If we multiply 1/3 times x, I'm going to come over to the side here and take a look. 1/3 times x is the same as multiplying 1/3 times x over 1 if I turn x into a fraction. When we multiply fractions, we multiply across the top and multiply across the bottom. If I multiply across the top, I have 1 times x equals x. If I multiply across the bottom, then I have 3 times 1 equals 3. So the first term, if we look at it as it is originally written, is 1/3 x. But as we're going to look at it, I'd prefer to look at it as x over 3. And so if we take the second term, 2/5 x, we write 2/5 times x over 1. We multiply across the top. 2 times x is 2x. Put in a fraction line. 5 times 1 is 5. And so we're going to look at this as 2x over 5. Let's rewrite our equation here. X over 3 minus 2x over 5 equals 5/6. sixth. Okay. Looking at your notes, you should notice that our next step, since there's no distribution, is to identify a common denominator. So I'm going to write that off to the side. I'm going to look at 3, 5, and 6. Well, 3 and 5 have a common multiple of 15. They both go into 15 evenly, but 6 does not. And so I think we need to jump up to 30, and we need to take a look at 30. 30 is divisible by 3, is divisible by 5, is divisible by 6. 3, 5, and 6 all go into 30 evenly. So let's take a look at what we can do. Let's start with our little arrows under our fractions, and we're going to turn each of these denominators into 30. So I'm going to write a line over 30 minus a line over 30 equals this fraction line over 30. I'm going to leave my numerators open just to start until I figure out what they're going to be. I'm going to show myself this work on the original equation. So I'm going to say 3 times 10 equals 30. And so if I multiply the denominator, I need to multiply the numerator. And x times 10 we can think of as 10x. Okay, 5 times 6 equals 30. And so I'm going to need to multiply the top. I'm going to do it out front here so it doesn't feel confusing. I'm going to say 6 times 2x is 12x. Okay, 6. If I move on to the final fraction, I have 6 times 5 equals 30, and so I need to multiply the top by 5 as well. And 5 times 5 is 25. All right, I have my new equation. Excellent. 10x over 30 minus 12x over 30 equals 25 over 30. And what we've discovered is that if every single term, all of them, have the exact same denominator, which we do, we have 30 and 30 and 30, then these will cancel if I multiply both sides by 30. Let's scribble them out because we're so excited we've eliminated those fractions. Excellent. So now what do I have left? I have 10x minus 12x equals 25. Well, 10x minus 12x is negative 2x equals 25. And so I'm going to come up here and I'm going to say I have negative 2x equals 25. I need to divide both sides by negative 2 in order to get that x alone, negative 2. And so those negative 2's cancel. I have x equals negative 25 over 2. Here's our answer. So once again, we made sure that everything was a fraction, and if the x's were separate, then we sort of tucked them into their fractions. We decided on a common denominator over here. We wrote it off to the side. We wrote a whole new equation with no numerators, with each denominator containing the common denominator. Then we did our work on the original equation to show how we turned the denominator into the common denominator, and then multiplied each numerator by the same number so that we are not changing the value of the fraction. Once our denominators were all the same, we crossed them out. We took what was left and solved the equation. Nice job.